Assalamualaikum and hi everyone. We are from Group 4 in Section 8, and in this video we'll be explaining to you what is pulse modulation and multiplexing. So let's get right to it. What is a pulse modulation? Pulse modulation is a technique that encodes information by converting analog signals into a digital format using a discrete process. It is essential for data transmission and control and widely used in digital communication, radar system, power control, and audio signal processing. Pulse modulation has several types, which are pulse amplitude modulation, pulse width modulation, pulse position modulation, and also pulse scope modulation. Pulse amplitude modulation is easily affected by noise, while pulse width modulation is less susceptible to noise, and pulse position modulation is less acceptable to noise compared to PAM. PCM is a pulse digital modulation where it will convert digital signals into a encoding process. What is a sampling theorem, Nyquist rate, and also aliasing? In sampling theorem, the sampling process involves multiplying of the analog signals with a periodic signal. In sampling theorem, the continuous signal can be precisely reconstructed if it is sampled at a rate of at least twice the highest frequency present in the signal. It is also called Nyquist-Shannon sampling theorem. And what is the Nyquist rate? Nyquist rate is the minimum sampling rate of Fs for an analog band limited signal. For the equation is Fs is greater than or equal to 2Fm. And also lastly is what is aliasing? Aliasing is the signals that are sampled at lower frequency than the Nyquist rate. We need to avoid aliasing because it will cause inefficient in modulation signal. Next, we will move on to quantization. Quantization is a part of pulse scope modulation. It is a process of converting sample analog signals into a binary value for digital communication. It involves dividing the signals into segments with different voltage level where each level is assigned with specific binary value. So as you can see in the figure, the blue line is the analog signal while the orange line is the sample signal. So to obtain the digital signal, it will undergo quantization level, quantization interval, and also quantization value, and we will obtain the digital signal.
Assalamualaikum and hi, I am Aina and I will continue the presentation with bit depth. Bit depth is the number of bits used to represent the amplitude of each sample data point. It directly determines the resolutions or precisions with which the analog signal is digitalized. Higher bit depth allows for more accurate representations of colors and sound level, wider dynamic range, reduced quantization noise, and improved overall quality. Why bit depth is important? It provides dynamic range. Higher bit depth allow for a larger dynamic range, meaning it can represent both very loud and very quiet sound with greater accuracy. Next is the signal to noise ratio. A higher bit depth generally results in higher SNR. It will reduce the amount of quantization error or noise introduced in the analog to digital conversion process. Lastly is the audio fidelity. In audio applications, higher bit depth can lead to a more accurate and detailed representations of the original sound, potentially resulting in a more pleasing listening experience. For examples, there are two different graphs that shows the 3-bit resolutions and the 5-bit resolutions. The green graph shows the original signals and the red graph shows the quantized signals. The range for the 3-bit depth starts with 000 until 111. And for the 5-bit resolution start with 00000 until 11111. The difference in the quantized signals and the original signals in the 3-bit resolutions is higher, therefore higher quantization error or noise. For the difference in between the quantized signals and the original signals in the 5-bit resolutions is lower, hence low quantization error or noise. Higher bit depth will need to increase storage and processing capabilities.
Now I will talk about multiplexing. Multiplexing is a process of combining multiple signals for transmission over a single communication channel. Multiplexing is essential in data communication and computer networks. It allows multiple signals to be sent simultaneously through a single data link. At the receiving end, all signals are received together. Sending signals separately is costly and requires extra. Types of multiplexing. Multiplexing have analog and signal. For analog, we have frequency division multiplexing, FDM, which each signal is sent on a different frequency. For example, radio and TV channel. And with next, we have wavelength division multiplexing, WDM. It uses different color of light to send data, often used in fiber optic cables. For digital, we have time division multiplexing, TDM. Signals are sent one at a time in turns. For example, telephone system. And TDM is divided into two types, which is synchronous TDM and asynchronous TDM. Synchronous TDM, when each device gets a fixed turn, even it has no data. Asynchronous TDM, which turns are given only when there is a data to send. Multiplexing is important because it makes communication system more easier, and it reduces the cost of infrastructure by reducing the number of wire or frequency needed. And it allows multiple signals to be sent together, which will save time and makes communication system faster and more reliable.
So next, what are the recent advancements in digital communication using pulse modulation and multiplexing? For pulse modulation, it includes pulse position modulation (PPM). It enhances for better noise resistance and higher data rates, particularly in wireless and optical communications. Next, we have pulse code modulation (PCM). It improves algorithm for quantization and encoding, reduce bandwidth while maintaining signal fidelity. And then for multiplexing, we have mode division multiplexing (MDM). Innovations in silicon photonics such as sub-wavelength, creating structures, reduce losses, and also enhance bandwidth. For noise reduction algorithm, it is advanced DSP techniques mitigate phase noise and frequency offsets for clearer signals. And also we have graphene modulators. It is used for ultra high-speed broadband communications and leveraging graphene's unique properties. So these innovations for applications used for underwater communication, right? It pulse modulation tailored for better performance in challenging underwater environments, and also for integrated photonics. It is compact systems for efficient signal multiplexing in data centers and telecom.
Hi, I'm Joey. I'm going to explain on misconceptions. First is the signals are not recorded properly. People assume that once multiple signals are combined using multiplexing method, it's impossible to separate them back and return to original form. This is not true because we are using demultiplexing algorithm to ensure the signals are recovered accurately. Second is multiplexing can cause signal interference. People assume that multiplexing inherently reduces interference between signals. This is not true since we have many modern techniques such as TDM, FDM, and CDM that are able to ensure the signals are isolated and the interference are minimized. Third is people assume and have a misconception that multiplexing can degrade the signal quality. This is not true since there are modern techniques such as error correction and amplitude modulation techniques to prevent signal integrity. Lastly is people are having assumed that misconceptions are widely useful in large net-scale networks such as telecommunication or internet, but however, it can be used and widely used in small-scale systems such as LANs and embedded systems. Hence, we come to a conclusion that pulse modulation is a fundamental technique used in communication systems, particularly in transmitting analog and digital signal over a communication channel. It has various forms such as pulse amplitude modulation (PAM), pulse width modulation (PWM), pulse position modulation (PPM), and pulse code modulation (PCM). PCM modulation acts as a bridge over analog and digital signal communication. PCM ensures high fidelity over digital data transmission and is widely used in telecommunications, audio systems, control systems, and radio technologies. Digital form of PCM modulation provide a better noise resistance over analog systems. With further advancement of electronic and signal processing, PCM remains significant for emerging technologies such as 5G and IoT.